Hey Pirates, real quick discussion of the study guide for the final over properties of matter. Again, I'm encouraging you to have already looked through your notes and tried to do the study guide from memory and using your notes just to kind of see where you would be as you watch this video. You can add and edit things. And so, the first part of the study guide asks you to compare and contrast physical and chemical properties. And so I would first define them. A physical property are characteristics of pure substances, where chemical properties are abilities to react with other substances. And examples of physical properties would include mass, volume, temperature, color, and so forth. There are some physical properties that are more useful, and we call them characteristic properties, and they're used to identify substances. And examples of those would be density, boiling point, melting point, etc. Both physical and chemical properties are ways to describe matter. Next part of the study guide asks you to compare and contrast physical changes. And so super important on this test that you distinguish in the question, is it asking you about a property or a change? Because that context will help you to answer the question correctly. So physical changes are things that change in form, but they don't change the substance. The chemical formula for the substance is still the same. And examples are phase changes, crushing things, tearing things, ripping things. All of those are physical changes. If we have something that's melting, for example, water, ice melts to be liquid water, it's still chemically water. So that is a physical change. If we were to take the water and break it down into hydrogen gas and oxygen gas, that would be a chemical change, and that would require some type of a chemical reaction. We no longer would have water. We now would have two new substances, hydrogen and oxygen, isolated, not combined. And so the definition for a chemical change is the substances changing through the process or through a reaction. We call the process of the chemical change a reaction. And it's always going to have new chemical formulas as products. We illustrate these with chemical equations. The original substances are called reactants. The newly formed substances are called products. The reactants interact and produce the products. And examples would be a piece of iron that rusts. The rust is iron oxide. And so the oxygen in the air reacts with the iron to create iron oxide. And then combustion of fuel, anything burning, you're going to have totally new substances. And so most fuels, when they combust, produce carbon dioxide, carbon monoxide, and then you have ash and so forth. So you have lots of new substances being produced when things burn. Remember from the pumpkin demo, we had evidence of chemical change, things like changing in odor, changing in color, change in energy or temperature, production of light, sound, fizzing and foaming, production of new substances. So again, just because you have one of those doesn't automatically mean you have a chemical change, but if you have multiple pieces of evidence, there's a pretty good chance you have a chemical change occurring. The next one says to insert a phase change diagram. So this kind of comes from our phase change simulator and our melting ice lab that we did. I took this image right from the lab so you could find it there. But ultimately, we have this line that has different legs, and there's a leg showing the substance in a solid state, and then it changes phase, then it's in a liquid state, heating up, then it changes phase, then it's in a gas state. And so I've labeled, and over here at legs A, C, and E, the substance is warming up as you go from the left to the right. If you go from right to left, it's cooling down. At legs B and D, the substance is changing phase. It's important for you to remember that we studied water, and so I would expect you to know that the temperature for the melting point of water is 0, and that's also the freezing point if we're cooling off the liquid. The temperature for the boiling point of water is 100 degrees Celsius, and that would be the condensation point if we're cooling it down. So you need to know those numbers for the test for water. And you need to understand kind of what they mean. That is the point at which the phase change is occurring for that substance, that level of energy or temperature. Next question asks you to be comfortable using the equation for density, calculating density. It's one of the ways that we measure matter, and the equation is density is mass divided by volume. Mass typically will be in grams or kilograms. Volume typically will be in milliliters. 1 milliliter is equal to a cubic centimeter, so it could be in cubic centimeters as well, and they are the same, just different ways to measure. And then a sample problem. If we had the density of a liquid that has a volume of 30 milliliters and a mass of 300 grams, we would divide 300 grams by 30 milliliters to get 10 grams per milliliter. Summarize how you would relate the melting point, boiling point, and surface tension of a substance to its relative strength of attraction between particles of the substance. And so for melting point and boiling point, the stronger the interparticle attraction, the higher the temperature at which the substances will boil, and that would also be the case for the higher the temperature for which the substance would melt. And then if we're thinking about surface tension, the stronger the interparticle attractions, the higher the surface tension the liquid would have. Again, that came from our Penny lab and from our phase change lab. Distinguish between a mixture and a pure substance. And so in your projects, one of the requirements was that you studied a pure substance, not a mixture. And that's because mixtures are real hard to identify specific properties because you have multiple things in the mixture that have multiple properties. And so a mixture is the product of distribution of one substance through another. Some real simple mixtures could be like trail mix. It has peanuts and M&Ms and cereal, different things in it. That's a macro mixture. A micro mixture might be salt water. It has salt dissolved in water. That is still a mixture, and it's a specific kind of mixture called a solution. So things that dissolve into liquids or solvents are called solutions, and those are mixtures. You still chemically have salt, sodium chloride, and you have water, and you could separate those and study each of them. A pure substance, however, does not have multiple things. Examples of pure substances are elements and compounds. And these all have unique chemical formulas. Finally, define the law of conservation of mass and relate it to chemical reactions and their equations. Well, the law basically states that matter or mass cannot be created or destroyed. It can only be moved around. And so in a chemical reaction, mass is conserved. All of the mass in the reactants will be found in the products after the reaction is complete. It may physically look like something has disappeared, but in reality, it has just become some form that is hard to see or find. And so that's, with the pumpkin demo, we captured that gas in the pumpkin to prove that there was a new substance there. Without the pumpkin, we would have not had evidence of a new substance other than the fizzing or foaming. And a chemical reaction or equation represents a reaction, and they show the reactants and then an arrow and then the products. And so you would have chemical formulas here being added together, and they yield, and you have chemical formulas over here would be representing the products or what is produced. The last thing I would encourage you to be aware of, you might take a look at for review, is in modules in Canvas, I have done some big idea discussions. So there's a link here to a discussion of the phase change simulation you might watch, discussion of the surface tension lab, and discussion of the phase change lab. So I would encourage you to view those as review for your final. If you have any questions, let me know. Good luck.